All right, y'all. So we are looking at trinomials. This part is where a lot of people have fallen off the train track. Um, and so when factoring trinomials, the first thing you got to remember is that factoring trinomials is kind of the opposite of distributing. It's sort of going backwards. So, like, normally when we multiply trinomials together, you have something like this. And what we're going to look at is our result. So when I multiply this together here, right, just follow the arrows, right, and then I combine like terms in the middle and I get 3. So when multiplying two binomials, you end up with this trinomial here. And most of the time you will. Obviously, there are certain situations like difference of squares where that doesn't happen, but most of the time you end up with a trinomial. And so at the end of the day, we are asking ourselves when we factor, when I look in this parentheses here, these initial, like the first terms in each parentheses, the 5x and the x, they multiply to give us 5x squared. Okay, when I look at the -2 or the -2 and the +1, those two multiply together to give us -2. So when we factor, we know what the first terms are going to multiply to give us, and we know what the last terms are going to multiply to give us in each parentheses. And so what makes things difficult is trying to get to this middle part here in green. And so when we do factor, we try to do a smiley face here, and we try to multiply these together to see if that will add up to that middle piece. Okay, so if I do -2 times x, I get -2x. If I get 5x times 1, I get 5x. If I add -2 plus 5 together, I get 3. And that's going to prove to me that that's my factor form. Okay, so when I go here to number 1 and I'm ready to factor this out, that's what I'm going to do. I'm going to break this up into two parentheses, and then I'm going to say, okay, this has to be broken up. So what multiplies to give us 2x squared? Well, it'll be 2x times 1x. What makes things difficult is now going to this last term and trying to figure out what's going to multiply to give us -12. And so what's going to multiply to give us -12 is a couple different things. So it could be -1 times 12. It could be 1 times -12. It could be -2 times 6. It could be 2 times -6. It could be 3 times, or -3 times 4, or it could be 3 times -4. All right, so you see how these combinations all of a sudden now can give us a headache. Well, this is just trial and error. It's just trial and error. It's just inspection. So you're kind of inspecting it. You're putting in numbers. You're trying it out, but you're only trying these numbers. So it's not like we have to go off the trail and go, oh, is it 17 and something, like, like those numbers don't need to come up because we're only focusing on these. Okay, and so your goal again is to get to a -5 here. Well, if you can remember the smiley face, then you know that these in blue are going to multiply with these in red at some point, one or the other. And so you can start trying to do stuff in your head a little bit to say, okay, I know this 2x is going to multiply by something that's going to go here. And so since I look at my numbers and I say, if I do try the first combination, right, let's think about that. So if I put a 12 here, 2 times 12 would be 24. Is there any way that I can get to -5 if the other number is going to be a -1 times an x? No, it's not going to work. Even if I switch, which is usually what ends up happening when you are trying to factor, is you switch the numbers. And so this thing is just very finicky. Okay, when you try to switch the numbers. So if I try to put a 12 here and a -1 there, well, I have 12 and -2. That's not going to work. And so that combination doesn't even get me close to 5, which means I'm not going to even utilize the other version of that. So these two I'm going to just cross out. So then I go to negative 2 and 6, and then I start to see, okay, well, negative 2 and 6. Well, that doesn't work. I get a negative 2 and a 12 on the outside here. Negative 2 and 12 does not add up to negative 5, right? And so that combination there isn't going to work. Negative 2 and 12. That gives us 8 or 10, right? So I'm not getting to negative 5. Well, first off, let me show you a thing here. If I look here, if I put a negative 2 here, I could technically make this smaller by dividing both of these by negative 2. Your parentheses should not have a GCF in them when you factor like this, when you factor these trinomials. So your parentheses should not have a GCF. So that's not going to work. If I try to put the 6 there, there's a GCF, so I know that's not going to work for me. But I get 6 and negative 4, which is 2, so that doesn't work. And so I'm like, okay. So then this is, again, just where if you can do stuff in your head, you can make things a lot easier for yourself. But now I have negative 3 and 4. So if I try negative 3 and 4, I get negative 3x and 8x, which is 5. And I'm like, whew, okay, I got 5, but the issue is I need a negative here in the middle. So I need a negative 5. Well, the only thing I need to do then to switch to make it a negative is change these signs. So it's going to be positive 3 and negative 4. So when I change the sign, sorry, of course I have to sneeze. So when I have to change the signs, I get positive 3 and negative 8, which makes it negative 5. And so that's going to be our combination there. And that's the factor form. All right. So for our next one, okay, I need something that's going to multiply to 3x squared plus 17x plus 4. And then that's going to, so I need to go to my parentheses here. And so if I say what multiplies to 3x squared, it's going to be 3 times 1. And then if I go to the 14, I say what multiplies to 14. Well, it's only going to be 1 and 14 or 2 and a 7. Now, technically, I could do negative 1 and negative and negative and negative again. So something you do have to remember that when you're multiplying, two negatives do make a positive. So that's a possibility. But because this is adding to 17, then it's not going to be the negative ones in this case. All right, so I'm trying to get to 17. So if I try a 7 and a 2, right? If I just do this in my head, that's going to give me 21 and 2, which is not going to work. So then if I try to switch, why does it take everything off? It's very sensitive. All right. And so if I do 7 and 2, that's going to give me 7 and 6, which is 13. So that doesn't work. So now I'm going to go with the 1 and the 14. Well, I'm not going to put the 14 over here at the end because 3 times 14 is going to make it too big. But now we get 14 and 3, which is 17. And so that is our combination. And that's it. That's our factor form. Okay. All right. Now, if there is no number in front of the x squared, makes it a little bit easier. So I have x squared minus 10x plus 16. What multiplies the x squared is x plus 16. What multiplies to give us positive 16. So that's going to give me 1 and 16, 2. Now, here's another trick. So now that I'm looking at this, I know I need to multiply to positive 16, but because I need to add up to a negative 10, then I know that my answers are going to have to be double negatives here. So now if I'm running through these, I have 1 and negative 16, negative 2 and negative 8, negative 4 and 4. And so this is going to give us our options. Now I need to add up to negative 10. So the good thing about not having anything in front of the x squared, no coefficient, is the x's are just 1x. So really these numbers are what I need. So I need to just see which of these two numbers will add up to negative 10. So that's going to give me the negative 2 and the negative 8. Because when I check it, right, that's going to give me negative 2. That's going to give me negative 8. So it's negative 10. And so whenever you have just an x squared, then it makes it a little bit easier to factor because you just have to find two numbers from the last number here that will multiply to that and add up to the middle. We don't have to do a whole lot of extra thought. Okay, and this one you probably can see it just from looking at the numbers. What is going to multiply to 15, but then add up to 16? Well, it's definitely not going to be 3 and 5, because if I try 3 and 5, it's just going to add up to 8. So if I do 1 and 15, that gives me 1x and 15x, which is 16x. Okay, now, kind of putting it together with what the last video was on, which is GCF. So if I have a trinomial, but I do have a number in front, what I would always do is check to see, can we divide to make these a little bit smaller? So I can divide both of these, all of three of these by 2, which will make this 3x squared minus 17x plus 14, which if I look, makes us look similar to number 2, 3x squared plus 17x plus 14. The only difference here is that's a minus. So we kind of remember, hopefully, from this last example or from example number 2, what's going to work. So this is 3x and x, and then what multiplies to 14, that will then add up to negative 17 in combination with the 3x and the x. It was the 14 and the 1. But remember, the 14 has to go here, the 1 has to go here. And so then when I look at the signs, I need to add up to negative 17. So that means both of these are going to have to be negative, because I get negative 14 minus 3, which is negative 17. So that is the factor form. And so then because I have a GCF, the GCF will just sit out in front, which means our final solution will just be that. Okay, see ya.